Let's get ready to rumble! All right. Hello, everyone. Mr. Minnick's my name. Math is my game. Today, we're introducing a topic that you've probably seen, you've probably used, but never in some of the contexts we're going to look at. So, first thing, example one. Write y equals 6 times x minus 3, the quantity squared, plus 5 in standard form. Now, if I asked a group of Algebra 2 students to do that, I know that there would be 2 out of a class of 25 that would get that right. And I know that there would be 23 out of the rest of the class who would get that wrong. So let me show you the wrong way that people would go about doing this. The first misconception that people have about this is that number 2. They forget everything that they learned in pre-algebra. They know that that's an exponent, but they don't understand how it works. They seem to mistakenly think that it needs to be distributed to this term and this term. And there's no exponent rule that says that. There never has been, there never will be. So let me be real clear about this. There is no exponent rule that says a plus b, the quantity squared, is a squared plus b squared. That rule does not exist. People make it up. They lie. I don't know what kind of stuff they think they're pulling. But that is not true. Okay? So to be clear, this is not true. This is not true. Okay? So in other words, a plus b, the quantity squared, does not equal a squared plus b squared. Okay? So that's where they go wrong in the first place. Everybody just wants to think, well, let's distribute this. So what they'll do is they'll say, so this is y equals 6 times the group x squared. And then if they did that, what would you make that 3 squared? What would you make that? A plus 9 or a minus 9? A plus 9, okay. So they'd make that a plus 9 and then plus 5. And then they distribute this and they get 6x squared plus, oh, thank you, good looking out, 54 plus 5. So that'd be plus 59, right? And that's what a lot of students would do, mistakenly. That's wrong. That's way wrong. So maybe we should distribute the 6 in first. Maybe we should distribute the 6 in first. Y equals the quantity of 6x minus 18, the quantity squared, plus 5. So that would be 36x squared plus 324 plus 5. So that would be 36x squared plus 329. And that's wrong also. So who can explain to me where I'm errant in my ways? What do I need to do first? I need to do the x minus 3 times x minus 3. Yeah. So the idea of foiling needs to be applied. When we have y equals 6 times the group x minus 3, the quantity squared, plus 5, what we need to realize is this really means this. We doing all right so far? Good. Okay. So when we do that now, some people when they get their cake, they just got to eat the icing first. Nothing wrong with that when you're eating cake. But when you're foiling, that 6 that's out front, some people get it twisted. Some people want to distribute it into both of those binomials, and it only needs to go into one of them. But I wouldn't do that. I wouldn't distribute it until after I do this product of these two things, right? Whoa, wrong one. I wouldn't distribute the 6 until I'm done foiling that. Everybody all right so far? Good. Okay, so this FOIL method, let's think about what it means, what it looks like. The FOIL method, it says if you have something like a plus b and you're multiplying it by c plus d, it means that you take the first terms, hence the f in foiling. And what do you do with the first terms? What do you do with them? Yeah. You multiply them. So you take the A and you multiply it by the C. Okay, so that's what the F in FOIL stands for. Then the O says, let's take our outer terms, our terms on the outside. So what are those? The A and the D, and we're going to multiply those also. So we take A and D and multiply those. And then the I for FOIL stands for the inner terms, the inside terms. So what are those? The B and the D, and we take, or the B and the C, I mean. What am I saying? The B and the C, we multiply those. And finally, the L in FOIL stands for the last ones. So here we take the B and the D. Here we take the B and the D, and we multiply those. So we've got all those products. Now what do? We got to times them? Well, we do, but this is a, whoa, I keep bringing that little circle back. So this is a term, this is a term, this is a term, and this is a term. How do we separate those? What do we do with this and this and this and this? There's something that needs to be between them. Not parentheses, some kind of operation. We're adding them, okay? They might have negative signs and we might be subtracting them, but those terms, we'll study chapter 5 polynomials. Terms are separated by addition, which is the same thing as subtraction. How we feeling so far, okay? Good. So that's the FOIL method. So let's back that thing up and let's do this one the right way. Using the FOIL method here, we're going to take our first terms, the x and the x, and find their product. And what's that give us? X to the squared. Awesome. So that's the F part of FOIL. And then when we do our O part of FOIL, we're going to have this x here times this negative 3 here. So that's going to give us negative 3x. Notice the terms are separated by addition or subtraction. The inner part of FOIL gives us this product here, which is another negative 3x. And then the last part of FOIL gives us a plus 9. How's everybody doing? Okay. So don't forget that there's that 6 hanging out front. And then there's that plus 5 on the end. And I heard somebody say we need to combine our like terms. Nice call. We do have to combine. I'm just having all kind of fun with these markers today. We do need to combine these like terms. So combining those, that's going to give us minus 6x plus 9 plus 5. So far, so good. Now we're ready to do something with that icing on the cake. Now I'm going to distribute the 6 in. Okay? Now I'm going to distribute the 6 through. So it's going to be 6x to the squared minus 36x plus 54 plus 5. So it's 6x squared minus 36x plus 59. And you might say, but that's what we had before. No, it's not. That's not what we had before. That wasn't what we said it was. Earlier, when we had the 6x squared, we were missing that middle term. You know, up here, oh man, just having all kind of fun with these markers today. Up here, that was wrong because we're missing that one term. If you're missing a term, it's not the same thing. So what do we think? Is that process pretty simple? Not bad? Make sense? So you're probably asking yourself, Self, he said that we were going to apply this in a different context than we've ever applied it. Well, I don't know if you've ever had to do this, but on an upcoming test or quiz, on a chapter test, you're probably going to have to do something like that. Okay? So let's look at another one. Example 2. Man, these markers. A long day. Example 2, also write in standard form. Write in standard form. Y equals x plus 6 and 2x minus 5. Okay, that's a quadratic function. That's given in an interesting form. I don't know if we spent any time talking about that one. I think I might have briefly mentioned it in passing. That's not quite an intercept form, but we could certainly FOIL something like this. And foiling something like this gets a little bit more challenging. A little bit more challenging. A lot of people, when they get the product of the first terms, they miss it. What's our first term product going to be? 2x squared. Nice, because we are multiplying x by 2x, so it's going to be 2x squared. So remember, FOIL stands for F OIL, first, outer, inner, last. Going to be a long day with this smart board today, I tell you what. So that's our F. That's our F. Let's look at the O. What's the O going to give us? Negative 5x. Yeah, it's this product of these outer terms. Good, negative 5x. So when a lot of people FOIL this, they mess it up on that inner product. They forget about the 2. What's my inner product here going to be? Plus 12x. Yeah, my inner product is plus 12x. And then my last product, of course, is the negative 30. Okay? So you might say to yourself, self, is there a way I can save myself time when I FOIL things out? Yeah, there is, and we'll get to that in a few minutes. Self, am I done with this one? No, I got to combine like terms. So my final answer here, would be y equals 2x squared, and then what? Plus 7x, and then minus 30. Awesome. How are we feeling so far? Okay? So the interesting thing is, it's this. Let's go to the calculator. Notice I have my TI Inspire CAS going. There's a reason I picked to use my CAS today. You'll see why in a minute. So if I wanted to go and graph that original function, the original thing we began with, the original thing we started with was x plus 6 and 2x minus 5. X plus 6 times the quantity 2x minus 5. So that's what that graph looks like. What I'm going to do now is I'm going to enter standard form of that function. So we said standard form was 2x squared, was it plus 7x? Plus 7x minus 30. How do you think that's going to compare to the blue one? Going to be the same, you think? One way to find out. Oh. Let's look at the table just to confirm. If we look at the table, can you see the y values in the table, how they compare? How's those y values comparing? They're the same. Okay. So here's what makes the TI Inspire CAS a little bit better than the regular TI Inspire. If we wanted to FOIL something like that quantity of x plus 6 and 2x minus 5, x plus 6 times 2x minus 5, the TI Inspire CAS will do that if you tell it how to. Now, it didn't expand that out for me. Hold on a minute. It didn't what? What did I just say? It didn't expand that out for me. It didn't expand that out for me. It didn't expand that out for me. Expand that for the variable x. So you might say, big deal. Well, it is a big deal because you want to see what we're going to do in a future chapter? In a future chapter, we will have one problem that covers the entire, both of the white dry erase boards on the sideboard. We will have one problem that covers that. We're going to have a problem similar to this. It's going to say, the problem is going to say, expand x plus y, the quantity to the 6th power. Actually, it's going to be to the 11th power, but I'm just going with 6 for now, because that's all that'll fit on my smart board. So let's think about what that 6th power means. That means x plus y times x plus y times x plus y times x plus y times x plus y. Do I have enough? 1, 2, 3, 4. No. Times x plus. Dude, we're going to have to. Yes. Dude, you're going to have to do that. So you could FOIL that, right? And you could FOIL that, and then you could FOIL that. If you have an odd exponent, well, there's a much easier way to do this one. But imagine if you had to do this. This would be x squared plus xy plus xy plus y squared. What's that middle term going to look like? X squared plus Hold on a minute. We have xy and another xy. Thank you. 2xy plus y squared. So we're going to have that. So we're going to get this. Oh my gosh. So we're going to have x squared plus 2xy plus y squared. We'll have all that again, and then we'll have it one more time, right? Or no, well, yeah, we'll have it three times. Dude. And then what do we do? Oh my gosh. This is going to take forever. This is going to take forever. So let's stop the show for a minute. Hold up. Wait a minute. Let's stop for a minute. Maybe we could be a smart aleck. Maybe we could do this. I expanded it, right? I expanded it. Well, wait a minute. No, hold on. Hold on a minute. Maybe we could look at the one piece of art in the room. Maybe we could look at one of the pieces of art in the room. And there's this weird looking triangle that has a row on it that goes like this. That goes 1, 6, 15, 20, 15, 15, 20, 15, 6, and 1. And maybe that has something to do with this. Maybe the coefficient of the first term is 1, which we don't write, and the first term would be x to the 6th. And the next term would have a coefficient of 6, and its x's and y's would be like this, x to the 5th y. And the next term's coefficient would be 15, and it would be x to the 4th y squared. And maybe the next term's coefficient's 20, x cubed, y cubed. And the next term's coefficient's 15, and it's x squared y to the 4th, and then plus 6 xy to the 5th, plus y to the 6th. Maybe that's it. Maybe that's it. Let's find out. Hold on a minute. Expand x plus y to the, well, I need another parenthesis in here. Expand that to the 6th power for the variable y. No, for the variable x. Oh, there it is. There it is. We're going to be studying that in a future section. So what does that have to do with foiling? Well, that doesn't really have much to do with foiling, other than the fact that sometimes foiling isn't good enough. Okay, so I think we got an idea of how foiling works, right? So what I'd like to do now is introduce you to something we're going to do next week in my Algebra 2 class, as I always do it. The incentive for winning is great. The incentive for trying is really good, because when we get to the next section, we're going to be factoring, and you have to be good at foiling to factor. But anyway, we're going to have a head-to-head championship where two people are face off, and the winner of those two people will go to the next round, and we're going to do a bracket. Anyway, we're going to get down to, I don't know, 4 or 6 people, and they're going to go into the conference room, and they're going to do some really nasty foiling problems, and the winner will get an automatic 100% on every Chapter 4 test. That's like almost guaranteeing that for that 9 weeks you're probably going to get an A. Because there's going to be a total of at least 4 Chapter 4 tests. Now, if you want to win, here's what you're going to need to know. You're going to need to know your perfect squares. I think some of you probably already know the first 10, but do you know the second 10? What's 1 squared? 2 squared, 4, and then 9, 16, 25, 36, 49. I can say them faster than I can write them. 64, 81, and 100, right? I think most of us know those. What you don't probably know equally as quick is the next ones. 11 squared is 121, 12 squared. And 13 squared, I always forget it. I know it's 1 something. Okay. 1 that. And then 14 squared is like 13, but the numbers I flipped a little bit. 196. And 15 squared reminds me of that road in Rome that goes by West Branch. That's hilly. 225. And then 16 is a power of 2. It reminds me of computer memory. 256. And then, well, the next one's 289. And then 324. And then everybody forgets this one, 361, and then 400. So you'll probably want to know those if you want to make it to the further rounds. And you want to be successful in the final round. You'll probably need to know those. The reason I say that is because this. I'm going to ask you to FOIL something like this. X plus 15 times x plus 16. Now, I know some of you know the lattice method. The lattice method, it works. I'm not going to discredit it, but it's slow. It's very slow. What I mean by that is the winners of this FOIL championship, they're going to have to say that this is x squared plus 31x plus 240. They're going to have to know it that quick to get into the next rounds. How did I do that math in my head that fast? Well, I'll show you. I already know the first term is going to be x squared. I think we all know that, right? I looked at this in the middle and I said, well, that's plus 15x, and that's plus 16x. And rather than writing plus 15x plus 16x, rather than doing that and wasting like 15 seconds, I just did that in my head. Everybody with me so far? Good. Now the last term, you're thinking, well, how did you do that so fast in your head? Well, I know that this is kind of like 15 times 15. And I know what 15 times 15 is because I know my perfect squares really well. 15 times 15 is 225, right? Well, 15 times 16 is really like 15 times 15 plus 1. So the deal is I have that 225 and I get another 15 on the end of it, and that's 240. Okay, so when we do this FOIL championship, I will be making up the things that you're foiling on the fly. I work these out in my head as we go. If you want to be fast at them, you're going to have to be razor fast. We'll start off with easy ones like this, x minus 3, x plus 2. We'll start off with ones like that. Anybody got that one already? X squared, what's the middle term? Minus x in the middle. And then the last term? Minus 6, right? Sometimes we do good old-fashioned drag races. X plus 1, x plus 2. What's that one going to be? X squared plus 3x plus 2, right? Sometimes people like to start cheating the system. So if they do that, I might switch the variables. I might go with square plus circle times square plus circle. It's the same thing. Foiling, what's square times square? Square squared. Now we're gonna have square times circle and another square times circle. So in the middle we would have 2 square circle. And then on the end we're gonna have circle squared. Right? To be clear, those are circles, not zeros. How are we feeling? So then where it gets difficult, where the going gets tough and the tough get going, is when we get into something like this. 3x plus 8 and 2x minus 5. Here's where people start falling off the hay wagon, so to speak. And I really take offense to the fact that people call them hay rides to this day. People always say, let's go on a hay ride. You don't go on hay rides in the fall. Somebody's been lying to you. Hay rides would be so uncomfortable, so itchy. There would be so many mice up there and cows and horses around you trying to eat the stuff off the wagon. Hay is what animals eat. Straw is what you do. You go for a straw ride. So whenever they call it a wagon ride, they're right. You've never gone on a hay ride. Okay, but that's another story. Okay. So what's my first term going to be? Oh, we're doing good so far. You know what a lot of people do when they get to these rounds? They get nervous. And they think it's 5x squared because they add the 3 and the 2 instead of multiplying them. But the first term is 6x squared. Now, again, if you want to be fast at this, you're going to have to kind of do the mental math in your head. You're going to have to do the mental math kind of in your head and think about that middle term. Think that this is going to be plus 16x. This is going to be minus 15x. So what's going to be the middle term? The middle term is what? Plus x. And then the last term? Minus 40. How are we feeling about this and next week? Okay. So you might ask yourself, why on earth would anybody in their right mind spend 3 days of class doing this? And the reason is real simple. When we get to chapter 4, section 4, and chapter 4, section 5, and chapter 5, sections 2, 3, 4, and 5, you're going to have to know how to do what's coming next in the curriculum. And that's another F word. Factor. You're going to have to take some kind of expression like this and you're going to have to unfoil that. You're going to have to unfoil that. You're going to have to go in the reverse direction, and you're going to have to make that the product of two linear binomials. Oh, man. So in other words, if you're good at foiling, you can check to see if your work's right. And that's why I'm spending 3 days out of class to go over foiling, because if you're good at foiling, you can check your work and you should be good at factoring also. So the deal is, to deconstruct this, we need to look at this 48, and we need to find 48's factor pairs. What do you mean 48's factor pairs? Well, 48 is really 1 times 48, and it's 2 times something, which is half of 48. 2 times 24. So maybe this is going to be x plus 2 and x plus 24, because 2 times 24 is 48. I'm hearing why not? Why not? Oh, because this is going to be plus 2x and this is going to be plus 24x, and that's 26x, but we want minus 16x. Oh, so maybe I should make this minus 24. Oh, so they both have to be negative. So maybe I need a different pair of factors. Something that when I add them both or subtract them both, I get that 16. So maybe I need to be good at finding factors of a number 2. Maybe it's 3 and 16. Oh no, not 3 and 16. 4 and 12. So the cool thing about math is this. Math is one of the only classes where you can tell yourself if you're right. Think about English. You write a paper, you submit it, and you really don't have a way of telling if it's right or not. The teacher grades it, and that's it. With math, with factoring, if you're good at foiling, you can foil out your answer to see if you factored it right. That's what I love about math. It has its own built-in safety net. Some kind of way to guarantee that you are right. Remember back on here, when we graphed both of those functions, we had a way to verify that what we did was right. Math always has another way to check yourself. That's what I love about it. It's great. Any questions so far? Comments? Concerns? Short debates? Long debates? Well, I'd like to give you a sneak peek, because I do want you to be fully equipped to handle what's coming next week. Those who make it to the championship round will need to be familiar with some special products. Some special products. There's a special product if you take something plus something in the same kind of expression, almost the identical expression, Almost the identical expression. So let me start this over. I'll make it nice and neat. I'll use my smart board the way it's meant to be used. So notice how that's almost the same with one little difference. Do you see how that's almost the same? Does anybody know what happens here? Let's FOIL it out and let's see what happens. What's the first term's product? A squared. What's the outer term's product? The outer product minus AB. Everybody with me so far? The inner term's product is what? Plus AB. And then the last product minus B squared. So wait a minute. Pardon me for asking this question, but what would happen with those? Oh, so those middle terms really aren't even there. So this ends up being just A squared minus B squared. Right? When we get into factoring, we'll see that that's a special case of factoring. Okay? But I want you to see that in foiling, that if you FOIL two products, the only difference is a plus sign and a minus sign in the middle term drops out. The middle term drops out. That happens every time. So, in some of the higher rounds, you're going to see something like this. 15x plus 8 times 15x minus 8. Hey, I'm only going to have two terms. All I got to know is my first product and my last product. That's it. What would my first term be? 225 x squared and then minus 6 folk. How are we feeling? There's another special product. There's another special product that says if we have something and we multiply it by itself, we have a squared plus ab plus b squared. We still get three terms, but the middle term is twice the product of the terms in the binomial. I know you probably don't like this one so much, but if we had something like x plus 6 times x plus 6, we're just going to double the product of this for our middle term. X times 6 is 6x, and double that's 12x. So we'd have x squared plus 12x plus 36. How are we feeling about that? We're almost done. Almost done. Last thing right here. Those who make it to the championship round, you're going to have fractions. A half x minus... Oh, everybody says they love decimals, right? Everybody says they love decimals. Everybody says they love decimals. Oh, maybe I'll be nice. Maybe I'll be nice. Maybe I'll be nice. Here we go. That'll be easier. So a lot of people just totally forget what happens when you take a half times a half. It's half times a half is 1/4. A half times a half is 1 times 1 over 2 times 2. So yeah, it's 1/4 x squared. Hey, wait a minute. Doesn't our middle term here drop out? So there is no middle term. Now, a lot of people say they love decimals. They suck at multiplying them. This is really minus a tenth, and this is plus a tenth, and a tenth times a tenth is 1 times 1 over 10 times 10, which is 100th, or as a decimal, because you all love decimals so much. Right? Okay. Finally, you're going to see some things with Greek letters. 12 alpha squared beta cubed plus 5 times 13 alpha squared beta cubed plus 7 maybe. Oh my gosh. Dude, I can't even multiply those things. Watch. It's real easy to multiply numbers. I know people are thinking I can't multiply this stuff. It's real easy to multiply stuff. Check this out. 12 times 13. If you know 12 squared, you know 12 times 13. 12 squared is 144, right? So 12 times 13 would just be another 12 on top of that. So you're going to get 156. Now what's alpha squared times alpha squared? Alpha to the fourth. What's beta cubed times beta cubed? Beta to the, if the bases are alike and you're multiplying, write the base and add the exponents. Okay, so that's our first term, right? Let's go down to the last term. The last term's easy, huh? The last term's easy, plus 35. Okay. Now the inner product, isn't so bad. Make sure you know your fives really well. 5 times 10 is 50. 5 times 13, well, that's just 15 more than that, right? So that's plus 65 in the middle, right? So plus 65 alpha squared beta cubed. That's our middle product, right? Now our last product, this is the one that's going to trip people up. And it's real easy to multiply 12 by 7. Don't think of 12 as 12. Think of 12 as 10 plus 2. You ever think to do that? So that's going to be 84, right? Right? So that's going to be 84 alpha squared beta cubed. So that's going to be 149. That's going to be 149 alpha, 149 alpha squared beta cubed in the middle. And that's it. What do you think? What if you had to multiply two numbers, and I'll end here. I know I keep saying this is it, this is it, this is it. What if you had to multiply something like 13 times 17? That's kind of nasty, isn't it? But you all know that the FOIL method works for binomials, right? Nobody ever uses a FOIL method to multiply because nobody ever showed you this. Maybe they did once and you forgot it. Check this out. You guys do this lattice method thing, right? I don't like the lattice method. I'm going to do this. 10 plus 3 times 10 plus 7. So 10 times 10 is 100, right? And 10 times 7 is 70. And 10 times 3 is 30. And 3 times 7 is 21. So what do I get? A 1 here. 10, that's a 12. Carry the 1. There you go. Merry Christmas. Have a nice day. That's it. It's been real. It's been fun. A shout out to the future Mr. Minnick. I hope everybody has the best weekend ever. And that's it. We'll see you next time.
Good.